doing 2.4, and it is division. When I talk about division, we're going to talk about long division. We're going to talk about synthetic. And we're going to talk about the remainder theorem. All right. So here's the thing. I know synthetic is your favorite. However, we can't use synthetic all the time. This works all the time. Synthetic is shorter, easier, quicker, but it only works if you have zeros. And the remainder theorem we'll get to in a minute. So, here's the one thing I want to point out. Last year when we did division, I had you put a little r and put your remainder, okay? This year we got to step it up a little bit. So, I want to remind you back in grade school what else we did with long division. So, let's say, I don't know, for giggles, we have 236 divided by 7. All right, sounds good. Super easy one. Just kind of show my point. 7 goes into 21 3 times. 3 times 7, or it goes into 23 3 times. 3 times 7 is 21. We draw our line, put a negative there, so we change our signs. And we subtract, we get 2. We bring the next one down. 7 goes into 26 how many times? 3 again, right? 3 times 7 is 21. We draw our line, change our signs. When we subtract, we get a 5. We're subtracting it, but I'm saying that because that's what I always say on long division. You're changing it. You're making it technically a negative 21. Okay? So, yeah, I'm saying it because it's the same way I'm going to say it with terms. All right? No, hold on. You guys. Now, last year I would have told you to put an R and write remainder 5. This year, we're going to take our remainder and write it over top of what we're dividing by. So this would have been 33 and 5/7, right? You just take and write it over top of what we divide by. Same thing's going to happen today. Now we're going to start with an easy one with long division. Okay, and here's example number 1. All right, this is what you're doing 1 through 6. We're doing, let's go with x, I don't know, to the third plus 2x squared minus 7x plus 1. And I want to divide by, we're going to do an easy one to start, x plus 3. All right, so this goes under the house. On the outside is our x plus 3. Now, what I said to you last year is, what times x is going to give me x to the third? X squared. So I put that above my x squared. X squared times x is x to the third. X squared times 3 is 3x squared. Then I said, draw your line, and now we're subtracting, so we're going to change our sign. X squared times 3. Then I said, draw your line, now we're going to subtract, so we're going to change our signs. So I have x to the third and negative x to the third. They cancel out. I have 2x squared, and negative 3x squared is negative 1x squared. So just like in long division, now I'm going to bring down my minus 7x. What times x will give me a negative 1x squared? Negative 1x, or negative x. Negative x times x is negative 1x squared. Negative x times 3 is negative 3x. Are we clear? We're good? We're going to draw our line, and now we're going to change our signs because we're subtracting. Negative 1x squared and positive 1x squared cancel out. Negative 7x and positive 3x is negative 4x. I'm going to bring down my plus 1. What times x will give me negative 4x? Negative 4. Now we multiply. Negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. We draw our line and change our signs. Because again, we're subtracting. Negative 4x and positive 4x, they cancel. 1 plus 12 is 13. So now when I write this, I'm going to put a plus 13 on top over x plus 3. So my final answer would be x squared minus x minus 4 plus 13 over x plus 3. So it's not any harder than what we did last year. Okay, questions out there? Give them to me. No questions. Rosie says no questions. Oh, we're going to. Don't worry. Yeah, I haven't gotten that far yet. I need to do a little bit tougher long division, but I wanted to, yeah. Do another one. Here we go. Example number 2. Example number 2. We're going to go with x to the 4th minus 2x to the 3rd plus 3x squared minus 4x plus 6. And we're going to divide by, I'm going to write underneath as division, x squared plus 2x minus 1. So this is a perfect example of where we can't use synthetic for this because we don't have a 0, right? We can't find a 0, so we have got to do this one by long division. So the top number or the top polynomial goes inside the house. Oh, that was a little crooked. The bottom one goes outside the house. All right, so the first thing I ask you is what times x squared is going to give me x to the 4th? X squared. So right above the x squared, I put x squared. Just because it keeps it lined up. It doesn't have to be. Okay? So now we're going to take our x squared, and we're going to multiply. X squared times x squared is x to the 4th. X squared times 2x is 2x to the 3rd. X squared times negative 1 is negative 1x squared. We're all good there. Now we draw that line underneath, and because we're subtracting, we go through and change all of our signs. X to the 4th and negative x to the 4th cancels out. I have a negative 2x to the 3rd and a negative 2x to the 3rd, so I have negative 4x to the 3rd. 3x squared and 1x squared is 4x squared. And now I bring down minus 4x. Again, same question again. What times x squared is going to give me negative 4x to the 3rd? Negative 4x. Negative 4x times x squared is negative 4x to the 3rd. Negative 4x times 2x is negative 8x squared. And negative 4x times negative 1 is positive 4x. I draw my line and I change my signs. All of them. That's why I say it that way. So negative 4x to the third and positive 4x to the third, they cancel out. 4x squared and 8x squared is 12x squared. Negative 4x and negative 4x is negative 8x. And we bring down plus 6. What times x squared is going to give me 12x squared? 12. Okay. So plus 12 goes right here. 12 times x squared is 12x squared. Move that up a little bit. All right. 12 times 2x is 24x. And 12 times negative 1 is negative 12. We're going to draw our line and change all of our signs. 12x squared and negative 12x squared cancels out. Negative 8x and negative 24x is negative 32x. 6 plus 12 is 18. Do I have anything else to bring down? Nope. So I'm going to go right up here, put a plus. My remainder I got, negative 32x plus 18, goes over top of what I'm dividing by. X squared plus 2x minus 1. All right. Plus 18 all over x squared plus 2x minus 1. All right, now, a couple things I want to remind you of. If there is a term missing, we have to make sure we use our zeros, right? So I want to do one of those very quickly. Yes. Yes. Remember those from last year? Example number 3. Let's say I have x to the third minus 1 divided by, let's go, x plus 1. I don't know. Okay. So in the house, we have x to the third, but we have 0x squareds, and we have 0 x's minus 1. I have to have placeholders. All right, one last time on long division. What times x will give me x to the third? X squared. Very good. X squared times x is x to the third. X squared times 1 is 1x squared. Draw my line and change my signs. My x to the thirds cancel out. I have 0x squared minus 1x squared is negative 1x squared. Bring down my plus 0x. What times x will give me negative 1x squared? Good, negative 1x. Negative 1x times x is negative 1x squared. Negative x times 1 is negative x. Draw my line, change my signs. My negative 1x squared and positive 1x squared cancel out. 0x plus 1x is 1x. Bring down minus 1. What times x will give me x? Should be 1 plus 1. 1 times x gives me x. 1 times 1 gives me 1. Draw my line, change my signs. My x and negative x cancel out. What is my remainder here? Negative 2. I have a negative 1 and a negative 1. So I have a negative 2. So up here I go plus negative 2 over x plus 1. All right. So we remember long division, right? It's not our favorite, but you only have 6 of them to do. It'll be all right. Synthetic. Let's talk about that. Synthetic division. You need the 0 of the divisor. Okay? Remember when we do synthetic, it is a long one-sided tic-tac-toe. Your coefficients go across the top. Your 0 of what you're dividing by goes out here. And we always bring the first number down. Then we multiply and we add. And then we multiply and we add. And we multiply and we add. Okay? So we're going to try a synthetic one. Here is example number 4. You are doing synthetic for 7 through 12. All right, so let's say I have x to the third minus 7x squared plus 2x minus, 5 divided by x minus 2. I don't know. All right, so first we do a long one-sided tic-tac-toe. Across the top are our coefficients. So we have 1x to the third, negative 7x squared, 2 x's, and minus 5. On the outside, what is the 0 of what we're dividing by? Positive 2. Very good. So now here's synthetic. We always bring, yes.
How come the 1 is not negative and the 2 is?
Huh?
See the 1 on the top left and the 2 on the bottom left?
Yeah, you get right here, you set this equal to 0 to get your 0. No, you're just taking the coefficients. Okay? All right. So first thing we do is we bring down the very first coefficient. It stays. Now we multiply. 2 times 1 is 2. And we add them together. Repeat the process. 2 times negative 5. And we add them together. 2 times negative 8. And we add them together. Now remember, this last one, it froze. Somebody's phone's going off. I don't know. There we go. This last one is our remainder. So here's how we're going to write it. First of all, this started as x to the third. We now get 1x squared minus 5x minus 8 plus negative 21 over what we're dividing by. Does this sound familiar? Okay. So let's do one more of these. It always goes down by 1 because we're dividing by an x. Here's example 5. All right, let's try something like about 9x to the third minus 7x plus 3 divided by x plus 2 again. I don't know. All right, so we draw a long one-sided tic-tac-toe. Across the top are our coefficients. We have a 9x to the third. How many x squareds do we have? 0x squareds, right? There's no x squareds here. Minus 7x's plus 3. Correct. We have to set it or get the 0. So now, as we divide, or we bring down the very first coefficient, which is 9, We multiply. Negative 2 times 9 is negative 18. We add them together. Negative 2 times negative 18 is positive 36. We add it together. Negative 2 times 29 is negative 58. We add it together. Again, this is our remainder. So our problem goes down by 1x. So we have 9x squared minus 18x plus 29 plus negative 55 over x plus 2. Questions? Do we have any questions? Nobody at all. You guys are sure? Okay. Move on to example 6. Example 6. Well, give me 2. This is 13 through 18. Using the remainder theorem, find the remainder. So let's say I give you f of x equals 2x to the third plus 7x squared minus 4x plus 1. And I tell you that k equals 3. Instead of putting this into synthetic, right, and using 3 on the outside, all we do is plug in 3. That's it. So we have 2 times 3 to the third plus 7 times 3 squared minus 4 times 3 plus 1. See, that's 18 plus 63 minus 12 plus 1. 81 minus 12 is 69 plus 1. 70. I tried to do it in my head. What'd you guys get? 68. Oh, that's because this is 27 right here. Yeah, I'm wrong on my first one. Just a second. So let's see. This is 27 times 2, so that's 54 plus 63 is 117. Minus 12 would be 105. Plus 1 would be 106. Look at you. Good job. And that's all we have to do for those. Okay? Is there any question on the remainder theorem? Yes, Trent. Example 7. Last one, you guys. You need to be listening. 19 through 24. Through 24, it says use factor theorem to determine whether the first polynomial is a factor. Is it a factor? So, let's say you have something like x to the third minus x squared plus x minus 1. And it starts off with x minus 1. And then it does this little, like, colon thing. It wants to know if x minus 1 is a factor of that. So we can do it one of two ways. You can do synthetic and see if it doesn't have a remainder. Or, what is our 0 here? So we can plug 1 in. So we have 1 to the third minus 1 squared plus 1 minus 1. If you get 0, you say yes. All right? All you have to do is use your 0. All right, and we are going to change that. We'll wait on 25 till tomorrow, okay? We'll change it to 24. All right? No. No.